Hi, folks. Welcome to 3.2 quadratic functions. Now, we're going to go ahead and get started with a what we know. And so some of the things we've talked about so far in this course are parent functions, right? And I might even list a few of those here. F of x equals x, or the absolute value of x, square root of x squared, and x cubed. Those are the ones that we've talked about so far. And for each of these and other random functions, we've talked about domain and range. And then lastly, we've talked about graph transformations and how no matter which parent function we start with, we can sort of shift them around the graph just by having certain numbers in certain places in our function. Now, what's new for today? And this might be really new for some of us. It might be not really new for others of us. So that's why we'll say what's new-ish. But we're going to talk about 3 different forms of the quadratic function, okay? In particular, we're going to look at the vertex form, the standard form, and the factored form. And then we're going to finish off with applications of quadratic functions, okay? So let's get started. Number 1, quadratic functions. So here's an XY table. We're going to plug these numbers that we've got for x, all of these numbers, plug them into the function, the quadratic function. And so -3 squared gives us 9. -2 squared gives us 4. -1 squared gives us 1. 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, all right? Now, if you want, pause here for a moment, go ahead and plot these points on the grid, and let's make sure that our answers match. Otherwise, I'm going to go ahead and do that right over here. All right, we should have 7 points that we can connect with a nice U shape. And this is our quadratic function, or the parent function, x squared. All right, now let's use the table and the graph and the equation to think about domain and range. Now, it turns out this domain is everything, all real numbers, because I can take negative numbers, I can square them, I can take positive numbers and I can square them, or I can take 0 and square it. All of that is fine, okay? But when we look at our graph, we might remember talking about this in chapter 1, that we don't see any function down here, right? There's no picture here. And likewise, if I look at the table, none of the values come out negative. In fact, the smallest value that can come out is 0. So our range here is from 0 up to infinity, okay? And the way we say we include 0 is we have a bracket, 0, comma, infinity. All right. Now, asymptotes, I wanted to put that on here because we've started to talk a little bit about asymptotes. There are no asymptotes for the x squared, okay? So I just wanted us to have that there to remember that not every function has some of those special characteristics like an asymptote, okay? All right, so this is our overview of the quadratic function, and let's talk about some characteristics that come up for all quadratic functions. So the graph of a quadratic function is called a parabola, okay? Not parabola, but it's a parabola. And I would say that there are 4 important characteristics for us to be able to recognize. And we want to be able to find these from a graph, but also from equations, okay? So the vertex of our parabola is either the minimum, or the maximum. Okay, it's either the minimum or the maximum. And what I mean by that is if I have a upset a regular parabola, that vertex is going to be right here. But if I have a parabola like this, the vertex is right up here, okay? So our vertex is either that minimum or the maximum. And we might even think about it like a turning point, okay? All right, next up, axis of symmetry. So the axis of symmetry goes through the vertex, okay? It goes through the vertex. And so, for example, our axis of symmetry might look something like this, or something like this, all right? And we'll draw a bigger picture on the next page. The y-intercept is going to be where x is 0, so 0, comma, a number, and the y-intercepts are going to be a number, or sorry, the x-intercepts are going to be a number, comma, 0. All right, so we want to be able to find all 4 of these characteristics on any parabola. So let's go ahead and sketch one here. I'm going to sketch a parabola. Looks something like this. And my vertex is right here, okay? And now I'm going to go ahead and draw in the axis of symmetry. So our axis of symmetry might look like this, and we'll label it axis of symmetry, okay? And in this case, let's see where our y-intercepts and our x-intercepts are, okay? So our y-intercept is right here. It's where our parabola crosses the y-axis. And then our x-intercepts are right here and here. This is one x-intercept, and this is another x-intercept, okay? So it works. These characteristics work if the parabola is facing up, but it also, we can label the same way if we say, oh, our parabola is now facing down, okay? We still have a vertex. We still have an axis of symmetry. And we still have a y-intercept. And we still have x-intercepts, okay? And so I just really want us to root ourselves in these pictures, because at the end of the day, we're just going to be trying to find different methods to find each one of those things, no matter the form, okay? And so that's where we're going to stop for part 1. Come on back for part 2, where we explore a little deeper into vertex form.